Take a look. Let's say you've got a wall coming in, say at that angle, I don't know. This is convenient for our purposes. All you do is, if this point would normally hit here, but we see, oh, the shadow actually hits the wall right here, so you would just go like this. Actually, let me not do that one. I would do this one. And you would end up getting something like this. To show you guys kind of what that would look like, again, you just do it point by point. So if a line's coming out like this and then it hits the wall, if this was the shadow, you would just go, and then it would be going like that up the wall. The thing to understand is this. Imagine if the wall isn't there, you're going to have a shadow like that. Okay? If the wall is there, you end up having a shadow like this. You see what I mean? So it's just like two intersecting planes. Yeah?
How did you find the middle of the shadow?
This one? Like in this area? This area? What I did here was, if like I had this Delilah, it comes out, and the light comes down like this and hits right there. Actually, the thing you guys need to be most careful of, let me do this on another sheet, because this one's getting a little bit cluttered. All these things that we're doing, we're basically just doing this. If you imagine, here's a Delilah, and here's a Delilah. You're casting the shadows, and this one comes in and hits here, and this one comes in and hits here, and you're kind of just playing connect the dots. As if these two are connected like this, then this one's connected like that. But then you're doing it a bunch more times. Now here's another conceptual thing that may help some of you. Okay, I'm going to do this very, very fast, but I think you guys will get the idea. Let's say I have a box like this, and I cast the shadows. Okay, now you guys, I am not recommending you do this way. But I want to show you that this actually does work. Okay? Do you see that this box here would be the shadow of the top of the box? Watch. If you draw a cylinder in this, the shadow of the cylinder will be encased by the shadow of the cube or box in the same way that the actual object is. You see what I mean? So if you don't get this, don't worry. But for some people, this really helps. If you think, if a cube's casting a shadow, and then we put a cylinder inside that cube, how can that cylinder cast any shadow outside of that cube's shadow? You see what I mean? The one's contained in it, the other one has to be contained in it. So if you start wondering if your shadow's going off the rails, like you're getting into some complex shadow on the wall or something like that, draw the shadow of the box. If it falls within that, you're probably fine. Okay, if it falls outside of it, you did something wrong. Does that make sense? All right. Oh, you guys, one last thing I need to show you about the cylinder, and then you guys should have enough information to go on. The one thing you have to be careful about with cylinders and how you draw them, and it may not seem like a big deal, but let's say I draw an ellipse like this, and I'm attaching my cylindrical sides to it. I'm attaching the straight lines. I don't know why, but some people do this, where they kind of, for lack of a better term, I say they tacked, it's like they tacked on the vertical to the side. You know, kind of goes, you don't want to do that. You actually want to draw the cylindrical side like this. You want to imagine it's coming in like this, and then it's coming down. You know, like this is feeding into the vertical. So you want it to do this, you don't want it to do this. All right? May not seem like a big deal, but it can make a big difference to how your drawing feels and whether it feels believable. When you tack on the line to the ellipse, it feels kind of wrong. Well, it is wrong, but it looks wrong too. Hey guys, now we already did this, right? We talked about the toilet tissue last time, right? Okay, because I'm going to save a little bit of time by just showing you the drawing and saying one thing about it. Okay, here's the key thing that I need you, this is the reason I was going to show it to you again. The key thing to remember is this, is if you have a horizontal ellipse like this, or a horizontal cylinder, the major axes are parallel because they share a minor. You see what I mean? So the major axes of a cylinder are always parallel. The other thing I want you to notice is take a look at these two ellipses. The one nearer to you is going to be, it's going to be a little larger, okay? It's going to be a little larger because it's closer, but it's going to be a little thinner. It's going to be a little bit of a, it's going to be a narrower degree ellipse, okay? A smaller degree ellipse. The back one is going to be physically smaller, but it's going to be fatter and rounder because it's farther, you know, because of the angle of view thing. You see what I mean? If it gets beyond this point, you're not even seeing the ellipse. So, does that make sense? That's the whole point of that diagram. That's why I thought we could save some time. Like that. All right, now,